Welcome back to HVAC for Beginners. Man, it's such a nice day out here. Sun's out, birds are chirping if you can't hear them. And today we're going to go over Superheat Part 1 and kind of apologize. There are going to be a few cars coming by. I thought I'd take a picture down here. This is kind of a runoff down here in the shaded area. And it's just absolutely a beautiful place to come down. It's peaceful and quiet at times. But let's go ahead and talk about superheat and a few things that are important. When you're doing your superheat for any reason, make sure when you're taking a temperature reading that your temperature reading is in the shaded area like you see here. But don't shoot it at the concrete. You want to kind of shoot it more towards the ground, like in an area of the grass or the dirt. Don't try to shoot on anything that is wood, concrete, or anything that would absorb heat, a brick wall of a house. So if you're outside, say on the outside of your home where your condenser is, find an area along that area that's shaded away from the house, kind of near like in an area like this. See how nice and shaded it is? And you can get a good ambient temperature, because that ambient temperature is so important when it comes to the process of a superheat, okay? If that number is not correct, your remaining superheat number is going to be incorrect, and the charge on your system is going to be off, 3 or 4 degrees, if not more. So it's just that important. Another thing you need to know about superheat is, and be careful, you'll kind of see the trees are kind of getting in front of the camera a little bit, is that it is a mathematical equation that is used. And when we get the mathematical equation set, that superheat for that certain ambient temperature is going to get your unit at the proper charging, so you don't have issues. Because what happens is an undercharged or overcharged system can overheat. The refrigerant that's actually in your HVAC system for your home, the proper charge keeps that compressor cool. So if it's undercharged and hasn't gone below the freezing point where they freeze, it can go into thermal lock, and basically the winding on your compressor will open, and then it'll shut the system down. The only thing that'll be running is your condenser fan motor. And then we'll get a no cool call from an HVAC technician somewhere coming to your home because something has happened. An overcharged system, slugging liquid does the same thing. It will cause it to overheat and do the same thing. So that's why superheat is so important. Nowadays, they have some gauges out there that are digital that actually will work off your smartphone, where you can hook up the low side and high side, and actually has 2 clamps for readings, and you can read the suction side temperature and the high side temperature. You can simultaneously get a superheat and subcool reading as you're charging. But for a standard homeowner, we're going to actually use manifold gauges in part 2 so that you can actually get the reading that you need from digital gauges, because I'm going to show you where there are temperature readings on your manifold gauges along with pressure, and it makes a real big difference. And it's so important, guys. So let's go ahead and get to it. We're going to go ahead and do a little bit of a reading on what superheat actually is. We're going to go over the platform I'm going to have you set, and then I'm going to actually go on and pen and paper like if you were at home doing a mathematical equation, and I'm going to show you how to set it up. On part 2, we will be coming back on that one and showing you how to do it live and on the scene. All right, welcome back. We're now back indoors. We are actually going to go over the superheat, as we were talking about, out there in that beautiful sun and in the fresh air. But let's go ahead and go over a little bit about what superheat does for the HVAC system. The amount of superheat is measured by the temperature difference between the refrigerant vapor and its saturation temperature at a given pressure. So remember, pressure and temperatures kind of correlate with each other. This temperature difference is known as the superheat, and is usually measured at the outlet of the evaporator coil. Nowadays, we do not do it at the evaporator coil. We do it at the condensing unit. It's just more efficient for the service tech out in the field and for the homeowner. By controlling the superheat, the HVAC technician can ensure efficient and reliable operation of the system by preventing liquid refrigerant from entering the compressor. Now, in some of my other videos, if you get a chance to go back and view them, the compressor is a vapor pump. It cannot compress liquid. In the event that it's compressing liquid, and the terminology is basically, and it'll speak of it in here, it's called slugging liquid, and it can cause severe damage. With that being said, like it says right here, which it can cause damage and reduce performance. Basically, the system, by preventing liquid refrigerant from entering the compressor, which we don't want, and causing damage, it reduces performance. So the proper superheat control is important because the insufficient superheat can lead to liquid refrigerant reaching the compressor, causing the compressor damage due to liquid slugging. And we call it slugging or surging. If one is overcharged, it's kind of really easy to detect. If you've been in the field for a while, it'll surge up and down, it'll bog down, and eventually damage the compressor. Back in the days, we had pot compressors before scroll compressors came along, and it would actually just crack the piston within a matter of an hour or two after that, or maybe a day. I've seen them go a week. That's about as best I've seen them do. Now, on the other hand, the excessive superheat can reduce the cooling capacity of the system and potentially lead to overheating of the compressor. So, two factors that fall into play here. An undercharged unit, if it hasn't reached below the freezing point, will cause the compressor to heat up and go into thermal lock. Overcharging it will also reduce the cooling capacity for the compressor and go into thermal overlock. Basically, what happens is the windings will open up on the compressor to protect itself, and it'll stay that way until it cools off and then resets, and then it'll go through the same process until the overheating or undercharged system is fixed and corrected. So let's go ahead and take a look at the mathematical part of it and kind of get a reading. And then after that, we're going to go over and I'm going to show you actually on paper with pen and paper, like you would if you were out in the field, on how to do it to kind of get a second view of how. So superheat mathematical process uses two primary numbers. The primary numbers that we will be using are 75 and 25. These numbers do not change. If you look at this pattern, this is kind of the pattern I'll have you set up on your piece of paper, which you will be viewing in the next setup that comes after we talk about this. Whatever the outdoor ambient temperature is the starting point of a superheat process. Without the proper superheat, like I said at the beginning of the video, make sure you take your temperature reading in the shade. So once you do that, you're going to go ahead and go through the process, minus it from 75, and you'll get 25. So if the outdoor temperature here I picked is 100, from 75 is 25. You're going to go to your next phase of it, which is part 2. You're going to divide 25 in half, basically by 2. That always will be constant. It'll always be divided by 2. There'll be no other number to divide by, just 2, not 3, 4, 5, or 10, just 2. You're just going to be taking that number and splitting it in half. The remaining number is 12 and a half, and then you're going to go to step 3, which is going to be the final step to give you your superheat reading for that ambient temperature. So 12 and a half minus from 25 is 12 and a half. So at 100 degrees outdoor ambient temperature, your superheat is 12 and a half degrees. That means you'll need a difference between the temperature reading on your suction side and the temperature reading on your suction side of your copper line going to the compressor. It must be a 12 and a half degree difference. So when you're charging it, you'll do so. And in part 2, I will show you that so you can see how this comes together. So without further ado, let's go ahead and get to the paper side of this so that you can actually see what it is it looks like when you put it on paper. Gives you a kind of a second view. The way I like to do it, we talk about it, we see it, and then we do it. Let's go ahead and get to it. Okay, so let's go ahead and do the superheat mathematical process here live on a piece of paper as if you were doing it right there with you. So get you a piece of paper, set it down, and we're going to go ahead and start. So go ahead and pause the video, come back and hit click. So we're going to go ahead and do this just like if I was out in the field and I had a pocket pad on me or my calculator. So, like I was telling you, we're going to go ahead and take 75, draw a line and put a minus. I'm going to take 25 and draw a line. And you're going to look something like that. Let's figure out what your ambient outdoor temperature is. So say I go outside, I shoot a reading, and say I get 94 degrees, okay? So what we're going to do is basically take that and we're going to bring it down here and put 94. So this is your ambient outdoor temperature, your AOT. Now, what we want to do is take the 94, minus it from 75, so that we can get the remaining number. Now, before we do that, we're going to go ahead and put our division in the middle. Makes it real easy because it's a three-step process. If we go ahead and subtract from this, we know that we're going to have to minus and bring this to an 8. That's a 5. 8 from 5 is what? So we know that 9 and 5, so we're going to have a 9. So that's 19. The next step is we're going to move that number over into here. We're going to divide it by 2. So let's go ahead and let you take a look. We're going to divide that by 2. Real easy, real simple. So 2 in basically 8 and 19, real simple. We know that 2 times 9 is 18 with a remainder of 1. Y'all see how you're doing that? So you have 1 left over. You're going to go ahead and take that 1 and split it in half. Calculator would be easier, but it's going to be 9.5. You will take your 9.5 and bring it directly over. Put it over here. And then you're going to subtract that. If you go ahead and start, you can make it easy. Go ahead and deduct the 5, gives you 20. So we're going to use your 9 number. Let's go ahead and use your solid number. If you remove 5 from it, it gives you 20. You still have 4 left over. Okay, that's going to give you 16. So if you just did it, 25, 24, 25, 24, 23, 21, 22, 20, 19, 18, 17. Then you're going to take this 0.5 from it, which is going to give you a 16.5 degree. Okay, this is your superheat that you're going to use to do the proper charge right here. So basically at 94 degrees ambient temperature, your AOT, your superheat, your SH, is 16.5. Right? So let's take a look at that. Basically, you took your 94 here, minus from 79, got 19. You divided that. You're going to take your remaining number and divide it by 2 as well to give your final number, because you're not going to use a solid number. And your calculator will do it for you. You'll bring it over here. You'll divide it from 25, and you'll get 16.5 for your superheat at 94 degrees temperature. Now remember, as your ambient temperature changes, your superheat temperatures are going to change. The higher your outdoor temperature is, the lower the superheat's going to be. The lower your ambient temperature or outdoor temperature is going to be, the higher your superheat. The reason why we use 75 and 25 is at 75 degrees, your superheat is 25. Gives you 100% to start with. Because 75 plus 25 is 100. That gives us 100% to start with, gives you a starting point. And it's real easy. But just make sure when you're shooting for your ambient temperatures that you're doing it in the shade. But don't do it in the shade on brick or on wood or on a tree. They all absorb heat. You want to shoot it towards the grass area or even somewhere where there's even some dirt. It just even playing field for your number. Because if you shoot in the sunlight, you're going to get, a 6 to 10 degree rise in temperature, and your superheat's going to be way off. It's not going to be right. And then when you go inside,
to check if you charge properly, and all of a sudden you notice that you don't have a 20 to 21 degree split, you have more of a 16 or a 17. That's because you used improper ambient temperature readings at the start. So always make sure you shoot in the shade, and that'll set you up. Okay, let's go ahead and try another number. Go ahead and set up your platform. Real easy and simple. Right? We're going to use 105 degrees outside today. All right? So you're going to take 105 from 75. Well, we know if we go ahead and take 75 from 100 is 25, you're going to add that other 5 to it, which will give you 30. You're going to divide 30 in half by that, which is basically 2 goes into 30 one time. To be 2, you leaves you over, you got 10. So you got 1, you have 15. So now you're going to take 15 from 25, which if you take it away, if you take 10 from it, it's 15. Another 5 is 10. So your outdoor AOT, outdoor temperature, or your ambient outdoor temperature, and SH for superheat. So guys, at 105 degrees AOT, your superheat is 10. And that's how you charge it. As you notice, remember I told you, the higher the ambient temperature, the lower the superheat. Real basic, real simple, guys. I hope you kind of got an understanding. I like to show it on there. We kind of read it, kind of show a scheduled platform, and then I like to do it by hand so you guys can actually see it in verbatim and how it works. So that's what it should look like, guys. So if you have any questions, leave a comment down below for me. Hit the subscribe button, thumbs up, notification bell so you get notified on the next video. If you're new, welcome to HVAC for Beginners, where we teach the homeowner or the beginner the starting basics of what HVAC is all about. We'll have more upcoming videos as we go along. These videos will get advanced once I get the basics down. Probably about 20 to 25 basic setups, and then we'll go into the advanced where there's quite a bit more. That, guys, I hope you enjoy Superheat Part 1. Part 2 is actually going to be out in the field where we're actually going to do it. I'll show you how to do the readings off your gauge. But before I do that, I'm actually, if you go back and look at the video, I'll show you what your gauges look like and read it. Kind of go back to that video, kind of go through it, but we're going to do it out in the field live.
Well, I hope that helped you on learning how to superheat Part 1, the mathematical process. Part 2 is coming up here soon. We're going to be live at a condensing unit with the gauges hooked up, temperature probe. We're going to start and get your ambient reading temperatures. We're going to go from A, B to C to the final D. We're actually going to go indoors and actually do a split reading. And with that, guys, if you're new to the channel, this is HVAC for Beginners, where we teach the homeowner and the beginner how to learn to take care of their unit so that you don't have to come out of the pocket at expense to have a service tech constantly come out to your home when little things go down, when you, the homeowner, can actually save you a lot of money by doing the maintenance work yourself. Hit the subscribe button, hit the notification bell, and hit that thumbs up. It really helps the algorithm. It gets information out there and gets this video out to others so that we can help everybody on the YouTube channel. And with that, this is Chris, your HVAC tech for HVAC Beginners. We'll see you on the next video.